Hi, I'm Stacy Langley, and this is information security on artificial intelligence and biometric authentication. Artificial intelligence in healthcare. When you think of artificial intelligence, you think of IBM's Watson, which I will talk about here in a bit. Something that is machine driven versus done by human. It takes algorithms and information to come up with a solution for stuff. Another one would be another famous artificial intelligence was the one that played chess. I can't remember his name, but played chess and won. But as far as healthcare, the uses for AI in healthcare is growing. And you can, as here, like for radiology tools, you um, they can read your x-rays and CTs and all these sometimes and pick up things that a doctor or a radiologist might miss because it's just such a minute detail that it would be missed. And that also goes along with expanding into underdeveloped regions in the US in the world, giving them access, because like as of right now there's more radiologists working in a half dozen hospitals in Boston than there is in all of West Africa. By having the artificial intelligence, it can be used to screen x-rays and all for tuberculosis, and they can achieve almost the same accuracy as a human doing that. And by having an app that they can deploy this information to, it gives providers in areas that have remote access and not having the radiologist that they need on site to do that. As far as like antibiotic resistance, we all know that antibiotic resistance is a huge issue today. Because of so many antibiotics given out, we're coming up with superbugs, and drugs aren't able to cure it because they're resistant to it because they have mutated to not react to that strain of antibiotic. And it costs, like C. diff alone costs $5 billion in the U.S. healthcare system for that, and it kills more than 30,000 people. Pathology images, they can use them in pathology because they can pre-scan it before the doctor looks at it and be able to tell them, hey, here's an area that is interesting that you really need to specialize in or really look at, because there's something here that's different than, because on a slide there could be a lot of things to look at, and this helps fix that issue because they can see stuff that might escape the human eye. Immunotherapy for cancer treatments. That is one of the newest things that are being done today, is using the body's own immune system to attack the cancer cells. But, right now only a small number of people are responding to that therapy. And because they don't, because it's so new and they don't have a precise and reliable method for identifying which patients will respond and what others. And by having the AI, they'll be able to analyze things and pull up that's targeted for that patient by the genetic makeup. And the problem is, one of the things right now is that they need more patient data because the therapies are still so new and not a lot of people have used it. So the more people they can get to use it and have the data sets needed, AI will leapfrog that use even more because it'll be able to narrow stuff down. IBM Watson is a well-known artificial intelligence program. Right now, IBM has the Watson system for health has basically 4 applications in healthcare. They have for genomics, drug discovery, healthcare management, and oncology. And what they can do, different ones can help, like oncology, they can use it to search through patients' their record and shift through all that data, because depending on the age of the patient and the health history, there is a lot of data that a patient can have. So by having Watson be able to use that, they can get through that information quicker. And also, should Watson and other tools like that be used more? And there's going to come a time that yes, that's going to be done regularly, because it can go through a lot of data quickly and accurately, but it also wouldn't be something I would depend on solely for that, because you still need the expertise and the experience itself, but it will be a great use for it. The ethical and the legal liability of Watson could be issues, because if they say Watson goes through all this information and spits out to the doctor that this patient should be on this medication versus either what they're already doing, or it might react with medications they've already been taken. So that can cause a malpractice claim, because the physician figures that Watson took all the other information into account when it recommended that particular medication or regimen, whatever the therapy that they were talking about. The basic limitations of Watson is that, Watson does not always understand the idiosyncrasies in the patient's healthcare record. But at the same time, he might also be able to identify those inconsistencies and idiosyncrasies that us as humans might overlook by mistake. So it's 50-50 on what it is. But the other issue that they have with the limitation is right now is what they call the black box problem, whereby where developers and users are unable to demonstrate how the system operates or derives its decision. And that can be kind of overcome by requirements of an audit trail with like a minimum level of detail to describe the process that was used to come to that decisions and stuff. And the other thing is that Watson and other clinical decision-making tools like that can create unrealistic patient expectations regarding the outcomes, because this computer said it needs to go this way. So the patient is going to think that this is what needs to be done, and when it doesn't happen, they're disappointed or such. Now into the biometric authentication. What is biometric authentication? It uses either your voice recognition, how you write your name, keystroke, not so much, but your face, fingerprints is a good one. Iris scans, your DNA, which is physical, that can't physically be changed. Your signature could be changed. I mean, they're both biometrics, but within healthcare, they're going more towards either the fingerprint and maybe even in some places the iris scan, but your fingerprints, the quickest and easy one. The advantage to it is the security. You know, most people, passwords are quite simple to a point, but you know, your passwords can be hacked easily. But your biometric, your fingerprint, that's unique to you. No two people have the same fingerprint. So you know, as far as security wise, your biometrics is pretty much unhackable for the most part. Not saying it can't be hacked, but for the most part, it can't. And then it also saves time. How it saves time, like when you're like in healthcare, you have doctors that work remotely. They might access their patient records after hours for home, or you know, and moving from place to place, computer to computer. By able to using the fingerprint, it'll sign into that computer instantaneously, and they don't have to remember passwords or take the time to do the passwords. And basically, it makes it that way. And you know, then the disadvantages is cost. The startup of it, because you have to buy the software, the devices, the programmers, everything related to setting up the biometrics, can get quite costly depending on the size of the healthcare system that would be starting it. The other thing is, depending on what the biometric type is, especially for hospitals and stuff, is that they can be unhygienic, because you have a lot of people that'll be using the finger base, the fingerprint, or the palm, like this vein for patients. So you know, it can be used by so many people that it's hard to keep it very clean. How can it be used in healthcare? Well, it can be part of a two-factor identification where you pair something like your fingerprint with like a keyword or a key card or a password or a key card to make access to something. You can use what they call the enterprise single sign-on, meaning you have one set of credentials that gets you onto everything. So say you use your fingerprint to sign in, it will sign into all the programs you use within that session. And then you can use it for patient identification, whether it's the palm print or a vascular palm vein pattern that's authenticated. You know, it's not used as widely, but it could help reduce the number of frauds and duplicate patient records because it's based on biometrics and not just name, address, name, date of birth information. Well, that is the end of my presentation. Hope you learned something a little bit about both biometric authentication and artificial intelligence. Thank you.